So I've said that functions are a rule of assignment. Well, they're relations, and relations are rules of assignment. So with that in mind, if I have a function that takes in a number and multiplies it by 2 and adds 1, that's kind of a mouthful to say, right? I don't want to have to say, let's talk about the function that multiplies the number by 2 and adds 1 all the time. Instead, I want to give it a short name, right? So what we're going to use is what's called function notation. Now this feels weird and it feels like something totally different than what we've been doing, but it's really not. So we will use the notation y equals f of x. So here's my function notation. F of x, here's how it's read. F of x equals or is 2x plus 1. That means, so f is the name of the rule. F represents the relation that takes numbers, multiplies them by 2, and adds 1. I'm using x here as a dummy, so you can almost imagine you've got a machine, right? You got a machine. Here's your machine. Okay? In goes stuff, out comes stuff. In goes numbers, whatever goes in, you multiply it by 2 and you add 1 and out comes whatever. So rather than having to say multiply it by 2 and add 1, I'm just going to call it f. That's what I'm going to call it because that's shorter. And in order to, again, not have to write multiply 2, add 1, I want to simplify this. I can do that with math, multiplying. I can just, 2 times a thing, adding plus 1. I just have to have a dummy input. So here is my x. So in goes numbers, out comes some other numbers. The rule is multiply by 2 and add 1. So you can almost think of these parentheses as this is what's feeding into the mouth of your machine. Out comes 2 times x plus 1. Okay, so with that in mind, big note. Note. F of x does not mean f times x. That doesn't even make sense in this context. The f of x is just saying, here's the rule that multiplies stuff by 2 and adds 1. And then in my parentheses, I'm going to write what I want to plug into my machine. It means the rule f with input x. That's what this notation means. So let's do a couple examples of evaluating. Okay, so example. Evaluate the given functions. The first one, let's just do that f of x is 2x plus 1. We want to find f of 3. What that means is I'm going to take the rule that multiplies input by 2 and adds 1, and I'm going to plug 3 into it. So my solution is f of 3. F takes in your input, multiplies by 2, and adds 1. So maybe it's helpful. Whatever your input is, multiply it by 2, and add 1, right? In this case, the input is 3. So I get 6 plus 1 is 7. Done. That's it. Oops. B. Let's do, now you can use any letter for functions. Usually F, G, and H are the first 3 that we'll start with, and then we can, move on to other letters if I need them. But usually F, G, and H will be enough. So let's say G is negative x squared plus 2x minus 3. And I want to find G of negative 1. So G says whatever your input is, square it in negative, plus 2 times input minus 3. That's the rule of G. And then the stuff with the x's was just a succinct way to write that. So when I do this, G of negative 1. So I want to plug negative 1 into my G machine. So everywhere I have an x, now I get negative 1. So negative 1 squared so I am going to use parentheses here. Negative 1 squared plus 2 times negative 1 minus 3, right? Make sure you're careful with your parentheses. So negative 1 squared is 1, but I still have the negative. 2 times negative 1 is minus 2 minus 3, so I get minus 6. So what that means is if I plug in negative 1 into my G machine, it spits out the number negative 6. Okay. As an extra, I'm going to add to our instructions. Okay, so this f of x or g of x is just a different way to represent the output, right? And on the previous page, I kind of wrote that and then glossed over it because I wanted to come back to it. Y equals f of x. Rather than writing the output as y, we're going to write it as f of x. And the reason is, for functions, if we know input, we know output. So for the functions, we want to somehow, like in the output, encode what the input was, right? So that's why we're going to write functions in this way. Okay, so output, y was our output. That means f of x is our output. So I used, well, I should have used red, but that's okay. In went x, out came f of x. In went 3, out came 7. So the point on the graph is my in out, which is 3, 7. On G, this graph, in went negative 1, out came negative 6. So negative 1, negative 6 would be a point on the graph. Okay, so that's just a slightly extra thing for our functions in and out. In is what you plug in, out's what comes out. You can think of it as x f of x, x f of x because we're replacing all y's with f of x. That's it. Again, the reason is we want to somehow encode information about the x when we write our information. Okay, so one last example of this type. Something a little bit different. I want to find, let's say, h of x is 2x squared plus 1, and I want to find h of x minus 3. Okay, this is not any different. H is the function that you take input, square it, multiply by 2, and add 1. That's what h does. So here, what am I plugging in? I'm plugging in the whole thing, x minus 3. That's the whole thing I'm plugging in. So this is 2 times x minus 3 squared plus 1. The whole thing. So I square that out, distribute, and I get, let's see, so I square x minus 3, that gives me x squared minus 6x plus 9. Distribute the 2, I have 2x squared minus 12x plus 18, then the plus 1, and I can combine like terms. And again, this is h of x minus 3, h of x minus 3, not times, but of. So what does my h look like if I put in something minus 3? Okay, final answer. So rewriting things using function notation is something that you're going to be doing. This is not as hard as you'd like it to be. So let's look at a couple examples, just very short ones. Here's a function, and I want to rewrite it using function notation. So 3x plus 2y equals 5. Now, we covered this in the last chapter. This is linear. It's ax plus by equals c. For function notation, all we're going to do is solve for y. Then we replace y with f of x. That's it, I promise. So to do this, so we have 3x plus 2y equals 5. So we subtract 3x and we divide by 2. Right? All right, so f of x is negative 3/2 x plus 5 over 2. Because what I've done in this previous line is I have a relationship that tells me if I have x, plug it in, y equals exactly this thing. That's exactly what function notation is about. It tells you how to find your output with a given input. All right, so that's it. Here's our example B, 4x squared minus y equals 3x plus 3y. Same thing, just solve for y and then replace the y with f of x. That's it. So for this one, I've got y's on both sides. It doesn't matter which side you decide to put them on. I'm going to do it by putting the y on the left-hand side. So I subtract 3y. That gives me minus 4y. And I also need to subtract the 4x squared. Okay, so I have minus 4y is minus 4x squared plus 3x, and then I divide everything by negative 4. So I get that y is y is x squared minus 3/4 x. That's it. Now in Hawks, this is part of a larger problem. So the first thing you do is this, and then you evaluate the problem at a certain point, and then they're going to ask you about the domain.